Welcome again, STEM students, to another lecture video. Today, we are going to learn about units. A unit is a definite magnitude of a quantity defined and adopted by convention or by law that is used as a standard for measurement of the same kind of quantity. That means that for one specific physical quantity, there can be many units, but all those units are only exclusive to one quantity. For example, the physical quantity mass can have units like kilogram, gram, pounds, and milligram. However, you cannot use kilogram as unit for volume or area or speed. Another thing about units is that units can be based on metric or English system. Units can also be converted within one system or from one system to another. There are two widely used systems of measurements in the world: the metric system and the English system. Let's start by discussing the English system. The English system is a system of weights and measures that evolved over time and was once the de facto standard throughout much of the world. It is defined by the British Weights and Measures Act of 1824 to be a standardized set of measures for the British Empire known as the imperial units. Usually, the basis for English system is a decree or law given by various monarchs. On the other hand, the metric system is the international decimal system of weights and measure based on the meter for length and the kilogram for mass that was adopted in France in 1795 and is now used officially in almost all countries. It is a rational system based on multiples of 10, and it uses where Greek prefixes which are established for multiples of 10, and it also uses Latin prefixes which were selected for the submultiples or for the negative exponents. Shown in this table are some examples of metric units and English units used for physical quantities like length, mass, area, speed, and volume. For length, we have metric units like meter, kilometer, centimeter, and millimeter. For length, we have English units such as inches, feet, miles, and yard. For mass, we have metric units such as grams and kilograms. For English units, we have pound and ton. For area, we have metric units such as square meter, square kilometer, square centimeter, and square millimeter. For English units, we have square inches, square feet, square miles, and square yard. Next, for speed, we have metric units such as meter per second, kilometer, and kilometer per hour. For English units, we have feet per second and miles per hour. For volume, we have metric units such as cubic meter, liter, cubic centimeter, and milliliter. For English units, we have gallon, quart, and ounce. One common characteristic of units is that they can be converted within one system, which means that units can be converted from English system to another English unit, or from metric system or metric unit to another metric unit. Most quantities are subject to conversions from one system to another, but there are exemptions, and one of them is time. Here are the conversion factor or conversion factors for time. 1 minute is equal to 60 seconds. 1 hour is equal to 60 minutes, which means that 1 hour is equal to 3,600 seconds. 1 day is equal to 24 hours, and 1 week is equal to 7 days. Those are the most common conversion factors for time. To be able to convert one English unit to another English unit, we need to use the conversion factors written in this table. 1 feet is equal to 12 inches. 1 foot rather is equal to 12 inches. 1 yard is equal to 3 feet. 1 mile can be equal to 5,280 feet or 1,760 yard. 1 ton is equal to 2,000 pounds. 1 gallon is equal to either 128 ounces or 4 quarts. I will show you 3 examples of converting from one English unit to another. Example number 1 is to convert 21 inches to feet. The first thing that you should always do in converting is writing or identifying the conversion factor. In this example, we need to convert inches to feet. Therefore, we should write a conversion factor that involves equivalence of inches in feet. Based on the table I showed before, 1 foot is equal to 12 inches. The solution should start by writing the amount which is to be converted. In this case, that is 21 inches. It is enclosed in parentheses to denote that the operation that you should use should be multiplication. Next, beside that, we will write the conversion factor in fraction form. It should be in such a way that the unit we need to convert will be cancelled. Since we are converting from inches to feet, we should write the magnitude with the unit inches in the denominator and the magnitude with the unit feet in the numerator, so that later on we can cancel the unit inches. Remember that when one unit is in the numerator, this one, or expressed as a whole number, this one, we will be able to cancel it by multiplying it with a fraction where the unit is written as denominator, this one, whole number, and then we have the unit inches in the denominator. Going back to this example, we can now cancel the unit inches. And then using your calculator, you will get the final answer, 1.8 feet. Now let's have example number 2. Convert 21 miles per hour to feet per second. The M here means miles, so we read mph as miles per hour. We are going to use 2 conversion factors here. We will have the conversion factor for time as well as for distance. 1 hour is equal to 3,600 seconds, and 1 mile is equal to 5,280 feet. For the solution, again, let us write the fraction form of 21 mph. And it will become 21 miles over 1 hour. Let us write the conversion factor for distance, which is 5,280 feet over 1 mile. The mile is in the denominator, so we can cancel the mile in our given. That's the mile in the conversion factor and then the mile in our given. We can cancel them now since one is in the numerator and the other is in the denominator. Next, we will write the conversion factor for time, which is 1 hour over 3,600 seconds. The hour is in the numerator so that we can cancel it together with the unit hour located in the denominator of our given. So this one is in the denominator. So for us to be able to cancel this, we should have the unit hour of our conversion factor in the numerator. Okay? Then we can cancel them out. Evaluating the numbers using our calculators, we will get the answer 31 feet per second. Example number 3, convert 21 miles per hour squared to feet per second squared. Again, we will have two conversion factors. For distance, we have 1 mile is equal to 5,280 feet. And for time, we have 1 hour is equal to 3,600 seconds. For the solution, let us write in fraction form 21 miles per hour squared. And it will become 21 miles over 1 hour squared. Let us write the conversion factor for distance, which is 5,280 feet over 1 mile. The mile, as you can see, is in the denominator, so we can cancel the mile in our given. Next, we will write the conversion factor for time, which is 1 hour squared over 3,600 seconds squared. The r is in the numerator so that we can cancel it together with the unit hour located in the denominator of our given. Notice that the hour is squared as well as the 3,600 seconds. That is because we are converting from hour squared to second squared. In evaluating, the numerical values that come with the units must be squared too. Okay, so the 3,600, you just don't put the square in the s. You also have to input in your calculator 3,600 and then you square it. Evaluating the numbers using our calculators, we will get the answer 0.00856. Using the rules of scientific notations, which is already taught in your General Chemistry 1, our final answer will become 8.6 times 10 raised to negative 3 feet per second squared. If you have already forgotten the rules of scientific notation, kindly revisit your notes in General Chemistry 1. Now, to convert from one metric unit to another, we need the prefixes seen on this table. Each prefix has an equivalent which is a multiple of 10. Deci means 10 raised to negative 1. Centi means 10 raised to negative 2. Milli means 10 raised to negative 3. Micro means 10 raised to negative 6. Nano means 10 raised to negative 9. Pico, or in other languages it's pico, it's equivalent to 10 raised to negative 12. Femto is equal to 10 raised to negative 15. And then each prefix has a symbol. The deci is lowercase d. The centi is lowercase c. The milli, lowercase m. The micro is the lowercase Greek letter mu. The nano, lowercase letter n. Pico, lowercase letter p. And then femto, lowercase letter f. We also have deca. We also have deca with symbol dA, equivalent to 10 raised to positive 1. Hecto, or h, 10 raised to positive 2. Kilo, or k, 10 raised to positive 3. Mega, or capital letter M, 10 raised to 6. Giga, or capital letter G, 10 raised to 9. Tera, or capital letter T, 10 raised to 12. And peta, or capital letter P, 10 raised to positive 15. Again, we're going to have 3 examples. Here is the first example in converting metric unit to another metric unit. You have to convert 21 centimeter to kilometer. Let's write the conversion factors. 1 centimeter is equal to 1 times 10 raised to negative 2 meters, because remember, the prefix centi is equivalent to 10 raised to negative 2. 1 kilometer, on the other hand, is equal to 1 times 10 raised to positive 3 meter. Since the prefix kilo actually is equivalent to 10 raised to positive 3. 1 cm. Why are there 2 conversion factors? Let me share with you these 2 rules. Number 1, use 1 conversion factor if the conversion involves a metric unit with prefix and a base unit. When we say base unit, these are the units without prefixes. Meter is a base unit. If you put prefixes with it, it can be centimeter. It's centi plus meter. If you put kilo with meter, it becomes kilometer. Other examples of base units are gram. So we have kilogram, centigram, watt, or W-A-T-T, which can be in kilowatt as well, and ampere, which can be expressed as milliampere. That's rule number 1. Rule number 2, use 2 conversion factors if the conversion involves 2 metric units with prefixes in them. Now, you already know the rules, so we can now go back to the example. For the solution, let us write the given 21 centimeters. Our first step should be to cancel the unit cm, so we will write the first conversion factor as 1 times 10 raised to negative 2 meters over 1 centimeter. After that, we can cancel the unit cm, and then we will write the next conversion factor, 1 kilometer over 1 times 10 raised to 3 meters. Input everything, cancel first, cancel the meter, and then input everything in the calculator, and you will get 0.00021. Moving the decimal point 4 places to the right gives us the final answer, 2.1 times 10 raised to negative 4 kilometers. Next, let's have example number 2. Convert 21 kph, or kilometer per hour, to meter per second. We have conversion factors. 1 kilometer is equal to 1 times 10 raised to 3 meters, and 1 hour is equal to 3,600 seconds. Notice that for distance, we will convert from kilometer to meter, which means that we will follow rule number 1. This means that we will only have one conversion factor for distance. Since time is already a factor in this conversion, we will have a conversion factor for time that is 1 hour is equal to 3,600 seconds. Remember that the word per, PER, or the slash you see in units indicate that we should write them in fraction form in our solution. Our given will now be written as 21 kilometer over 1 hour. Our first conversion factor will be written as 1 times 10 raised to 3 meter over 1 kilometer so that we can cancel kilometer. Our second conversion factor will be written as 1 hour over 3,600 seconds so that we can cancel the unit hour. Input everything in the calculator and you will get 5.8 meters per second. Let's have example number 3. Convert 21 meters per second squared to kilometer per hour squared. Our conversion factors will be 1 kilometer is equal to 1 times 10 raised to 3 meters and 1 hour is equal to 3,600 seconds. Notice that for distance, we will convert from m to km, which means that just like in example number 2, we will follow rule number 1. This means that we will only have one conversion factor for distance. Since time is also a factor in this conversion, we will have another conversion factor for time, that is 1 hour is equal to 3,600 seconds. Our given will be 21 meters over second squared, as you can see on the screen. Our first conversion factor will be 1 kilometer over 1 times 10 raised to 3 meter so that we can cancel meter. Our conversion factor for time will be written as 3,600 seconds squared over 1 hour squared. And just like in the other example, remember that we should also square the numerical value of 3,600. So now we can also cancel the unit second squared. Input everything in the calculator and you will get 272,160. By moving the decimal point to the left 5 times, our final answer becomes 2.7 times 10 raised to 5 kilometer per hour squared. That's all for the first part of our discussion about units. Have a nice day and see you again in part 2.